More than 90 million Americans are under severe weather alerts this weekend, and forecasters say the atmospheric pattern driving those threats may continue for much of the next 10 days. That's what makes this forecast so unusual. This isn't one hurricane racing up the East Coast or one blockbuster storm dominating every headline. It's a sequence of weather systems that could repeatedly produce severe thunderstorms, torrential rainfall, flash flooding, damaging winds, and dangerous heat across different parts of the eastern United States. The real story isn't any single storm, it's the pattern connecting them. When meteorologists begin highlighting multiple hazards across several consecutive forecast periods, they're no longer focused on one day's forecast. They're asking a much bigger question. Has the atmosphere shifted into a configuration capable of producing repeated impacts instead of one isolated event? That's exactly what we're breaking down today. What forecasters are seeing, why they're paying such close attention, what the science says with confidence, and just as importantly, what it doesn't. Now, to be completely clear, this does not mean the entire East Coast is about to experience a historic disaster. Current forecast guidance does not show one catastrophic storm affecting every state at once. Instead, it points toward an extended period during which different communities could face different hazards on different days. That distinction matters because it's the difference between one dramatic event and a prolonged stretch of elevated weather risk. If you enjoy evidence-based weather and earth science analysis, not hype or speculation, consider subscribing. We follow the data, explain the science behind it, and update the story as new forecast guidance becomes available. So where does this concern begin? It starts thousands of feet above the ground. One reason forecasters are watching this so closely is that the large-scale atmospheric pattern over North America isn't expected to change very quickly. Instead of one fast-moving disturbance passing through and allowing calmer weather to return, forecast models show multiple upper-level disturbances moving along a broad trough covering much of the eastern half of the country. At the surface, several frontal boundaries are expected to move through the same general regions over consecutive days. At first glance, that might sound like fairly typical summer weather. After all, thunderstorms are common during July. But this is where the science becomes more interesting. Thunderstorms don't develop simply because it's hot outside. They need moisture, atmospheric instability, and some mechanism to lift warm air into the atmosphere. Over the next several days, forecasters expect those ingredients to overlap repeatedly across portions of the East Coast and nearby regions. That's an important distinction. The concern isn't just that storms will form. The concern is that the atmosphere may continue rebuilding favorable conditions after each round moves through. Think of the atmosphere like a rechargeable battery. A single thunderstorm drains some of that energy locally. Under normal circumstances, cooler and drier air often follows behind, giving the atmosphere time to stabilize. But when warm, moisture-rich air keeps flowing northward while new weather systems continue arriving from the west, that battery can recharge surprisingly quickly. That's what forecasters are evaluating right now. If the atmosphere repeatedly reloads, each new disturbance has another opportunity to trigger heavy rainfall and severe thunderstorms. By itself, that doesn't guarantee widespread damage. Weather forecasts are never guarantees. But it does increase the probability that multiple rounds of hazardous weather could affect different areas over several days instead of everything ending after one storm. Here's the part many headlines skip. The greatest risk doesn't necessarily come from the strongest thunderstorm. Sometimes it comes from storms that repeatedly move across the same location. Meteorologists call this training because individual storm cells follow similar paths, much like train cars moving along the same track. When that happens, rainfall accumulates much faster than drainage systems, streams, and rivers can handle it. That might not sound dramatic at first, but history shows that flash flooding often develops not because of one extraordinary downpour, but because rainfall keeps returning before the ground has time to recover. That's why forecasters spend so much time analyzing atmospheric moisture. Current forecast discussions indicate that deep tropical moisture is expected to remain available across parts of the eastern United States during this pattern. When unusually moist air combines with slow-moving or repeatedly developing thunderstorms, rainfall rates can increase significantly in localized areas. Notice what that does not mean. It does not mean every city along the East Coast will experience flooding. It does not mean every forecast will verify exactly as projected. And it certainly does not mean a single historic storm is about to strike the region. Instead, the data points towards something more subtle, but potentially more important. A weather pattern capable of producing multiple opportunities for hazardous conditions over several consecutive days. That explains why forecasters are paying so much attention to the broader atmospheric setup instead of focusing on one individual storm. Understanding the forecast pattern is only the first layer of evidence, though. The next question is even more important. Why can repeated rounds of ordinary-looking storms sometimes become far more dangerous than one powerful storm by itself? Here's where the forecast becomes much more significant. Most people naturally focus on the strongest storm. Meteorologists often focus on something different entirely, the number of opportunities the atmosphere has to produce dangerous weather. That's because repeated events can sometimes create greater overall impacts than one exceptionally powerful system. Imagine two neighborhoods receiving exactly the same amount of rain over a week. One gets it all in a single afternoon. The other experiences several rounds of thunderstorms every day for nearly a week. On paper, the rainfall totals may look similar. In reality, the second scenario often places much greater stress on rivers, drainage systems, emergency services, and local communities because the atmosphere never really gives the region time to recover. That's the larger concern forecasters are watching today. Every new round of storms has the potential to build on what happened before it. The science behind this is surprisingly straightforward. When rain falls, some of it soaks into the soil, while the rest flows into streams, rivers, and storm drains. After one storm, much of that water can still be absorbed if the ground hasn't reached its limit. But after repeated rainfall, that natural storage capacity begins disappearing. Think of a dry sponge sitting on a kitchen counter. The first cup of water disappears almost instantly. The second fills much of the remaining space. By the third or fourth cup, the sponge can't absorb much more. Nearly everything simply runs off the surface. The ground behaves in much the same way. That's why forecasters don't only ask how much rain might fall tomorrow. They're also asking how much rain has already fallen over the previous several days. Soil moisture, river levels, and watershed conditions become just as important as tomorrow's forecast itself. This is the part many headlines never explain. Flash flooding isn't always caused by extraordinary rainfall. Sometimes it's caused by ordinary rainfall falling on ground that has already reached its limit. That distinction completely changes how meteorologists evaluate risk. Historical events illustrate this remarkably well. Across the eastern United States, some of the most damaging flood disasters in recent years weren't produced by major hurricanes. Instead, they developed when slow-moving thunderstorms repeatedly crossed the same communities while the atmosphere continued supplying deep tropical moisture. One round saturated the ground. Another overwhelmed drainage systems. A third produced flash flooding that seemed disproportionate to the intensity of any individual storm. That's why forecasters become increasingly concerned when weather patterns begin repeating themselves. The pattern itself becomes part of the hazard. At first glance, the forecast maps for the coming days may not appear extraordinary. There isn't one massive circulation dominating the entire East Coast. Instead, forecast discussions describe several disturbances moving through a broad upper-level trough, while frontal boundaries repeatedly interact with warm, humid air flowing north from the Gulf of Mexico and the western Atlantic. Individually, none of those ingredients is unusual during midsummer. Collectively, they deserve much closer attention. Warm air holds more moisture than cool air. When that moisture-rich air is repeatedly lifted along frontal boundaries, thunderstorms can develop efficiently, producing heavy rainfall in relatively short periods. If steering winds remain weak, or storms repeatedly develop along the same corridor, localized rainfall totals can increase rapidly. Here's an important distinction. None of this means forecasters know exactly which county will receive the worst impacts. Weather prediction simply doesn't work that way. Modern forecast models have become remarkably accurate at identifying large-scale atmospheric patterns several days in advance. Predicting the exact location where one thunderstorm will stall 5 or 6 days from now remains much more difficult. That uncertainty isn't a weakness of forecasting. It's an inherent characteristic of atmospheric science. In fact, One of the strongest indicators that forecasters are taking this pattern seriously is that different forecasting models continue identifying similar large-scale conditions, even though they still disagree on some local details. When independent model guidance repeatedly points toward an active weather pattern, confidence in the broader setup increases even while uncertainty remains about specific communities. This is exactly where science differs from sensational headlines. A headline might ask whether the East Coast is facing disaster. Meteorologists ask a much more practical question. Where is the atmosphere most likely to support repeated hazardous weather, and how confident are we in that assessment? Those are two very different conversations. Another common misconception is that dangerous weather always arrives with dramatic satellite images of giant hurricanes. Reality is often less obvious. Some of America's deadliest flash floods have developed from clusters of ordinary-looking thunderstorms rather than famous tropical cyclones. They rarely become national headlines until after the flooding has already begun. That's why forecasters place so much emphasis on rainfall potential instead of storm appearance. The atmosphere doesn't need to produce the strongest storm of the year to create serious impacts. Sometimes it only needs enough instability, enough moisture, and enough repetition. That's the pattern we're seeing emerge over the next several days. To be clear, this still does not guarantee widespread flooding or severe weather across the entire East Coast. Forecast confidence remains highest regarding the persistence of the atmospheric pattern, not the exact location or severity of every individual storm. But that alone changes how emergency managers prepare. Instead of planning for one isolated event, they're preparing for the possibility that weather hazards could return repeatedly as new disturbances move through the same general regions. So far, the evidence has built a consistent picture. Forecast guidance points toward multiple rounds of active weather. The atmospheric setup explains why those rounds may continue. Historical events demonstrate why repetition matters more than many people realize. But there's still one critical question left to answer. How confident should we actually be in this forecast, and what does current science say about what could change before the pattern finally breaks? By this point, one conclusion should be clear. The biggest concern over the next several days isn't one extraordinary storm. It's the possibility that the atmosphere may continue producing multiple rounds of hazardous weather before this larger pattern finally weakens. That's an important distinction because it's also where the science becomes much more measured than many headlines suggest. Weather forecasts are probabilities, not promises. Even when forecasters have high confidence in the overall atmospheric setup, they know that countless smaller details can still influence exactly where the heaviest rain falls, which communities experience the strongest storms, and which areas escape with little more than passing showers. That's why you'll often hear meteorologists speak with two different levels of confidence at the same time. They're highly confident about the large-scale pattern. They're much less confident about neighborhood-scale impacts several days in advance. Those two statements aren't contradictory. They're simply describing different parts of the forecast. Here's why that matters. Current forecast guidance consistently points toward an active weather pattern capable of supporting repeated thunderstorms, heavy rainfall, and localized flooding across portions of the eastern United States. That broad signal has remained relatively stable across successive forecast updates. But stability in the overall pattern doesn't automatically translate into certainty for individual communities. A small shift in a frontal boundary by just a few dozen miles can dramatically change where the heaviest rain develops. A cluster of morning thunderstorms can reduce afternoon instability. Slight differences in wind patterns several thousand feet above the surface can determine whether storms keep moving or repeatedly pass over the same location. Those are details that become clearer only as each day approaches. That's exactly why forecasters continuously update their guidance. Forecasting isn't about making one prediction and hoping it stays correct. It's a process of refining the picture as new observations from satellites, weather balloons, radar networks, aircraft, and surface stations are fed back into increasingly sophisticated computer models. Every new observation slightly improves our understanding of what the atmosphere is doing. That's one reason forecast accuracy has improved dramatically over the past several decades. At the same time, the atmosphere remains one of the most complex natural systems on Earth. No model can eliminate uncertainty completely. That's why responsible forecasting always includes both confidence and caution. So what do we actually know with confidence today? We know that forecasters are monitoring a persistent atmospheric pattern expected to keep parts of the eastern United States active for several more days. We know that repeated opportunities for thunderstorms generally increase the risk of localized flash flooding, especially where rainfall occurs over the same areas more than once. We know that damaging wind gusts, dangerous lightning, and isolated severe storms remain possible whenever these ingredients come together. And we know that weather hazards don't have to affect every state or every community to become significant. What remains uncertain is equally important. No one can say today exactly which city will receive the heaviest rainfall several days from now. No one can identify every location that may experience flash flooding. And no responsible meteorologist is claiming that the entire East Coast is about to experience one historic disaster. Those aren't weaknesses in the science. They're honest reflections of how atmospheric forecasting works. This is the part that often gets lost in social media headlines. Extreme weather doesn't always announce itself with one dramatic event. Sometimes it develops through repetition. One storm weakens trees, another saturates the soil, a third overwhelms drainage systems. Individually, each event may appear manageable. Together, they create a much larger problem. That's why emergency managers encourage people to pay attention not only to today's forecast, but also to how conditions evolve over several consecutive days. Preparation doesn't have to be complicated. If you live in an area where heavy rain or severe thunderstorms are possible, keep wireless emergency alerts enabled on your phone. Check updated forecasts from the National Weather Service each day rather than relying on a forecast you saw several days ago. Never drive through flooded roads, even if the water appears shallow. And if multiple rounds of storms are expected in your area, remember that conditions on the second or third day may become more hazardous than they were at the beginning of the week. Small decisions made early often have the biggest impact when weather conditions begin changing quickly. So let's return to where we started. More than 90 million Americans are currently under severe weather threats. That's an attention-grabbing number. But it isn't the most important story. The more important story is the atmospheric pattern behind those alerts. Current evidence suggests that this pattern could continue producing multiple rounds of hazardous weather before finally breaking down. That doesn't guarantee widespread disaster. It doesn't mean every forecast will verify exactly as projected. And it certainly doesn't mean every community along the East Coast will experience dangerous conditions. What it does mean is that forecasters have identified a weather setup that deserves close attention not because of fear, but because repeated hazards often create greater impacts than any single storm. As always, we'll continue following the latest forecast discussions, explain what the new data actually shows, separate confirmed science from speculation, and update you as this pattern evolves. If you found this breakdown helpful, don't forget to subscribe, because the atmosphere keeps changing, and when it does, we'll be here to break down the science behind it.